Hey guys. All right, what we're going to do is we're going to start looking at a series of videos. You'll get these periodically. So when you're watching the video, what I expect you to do is be actually taking notes on the video. In other words, they're kind of like you're in class. Because sometimes on a podcast, I may have you pull out your notes and give me something from your notes. So if you don't take notes, you won't be able to get those things correct on the podcast. Okay? Now these are things you should already know, but there are rules and properties and those kind of things you need to take notes on. So what I normally will do is I'll put a PowerPoint up and kind of talk you through the PowerPoint. So that's the way the videos will normally work. All right, so let's see if we can get it to do this time. All right, so we're going to start by watching a video, looking at a PowerPoint about properties. Now, I always tell people if I can only teach people one thing in math, I would teach them properties because everything else is based on those properties. And sometimes you've been taught those properties like once, one day, and then they're gone and you never see them again. So that's one of the reasons I think that you struggle in algebra because you don't know the properties. So let's kind of talk our way through some of the real important properties in mathematics, okay? And again, I know you know these, but it makes me feel better. Now, several of these are about addition and multiplication, so I'm going to flip between those two operators. Now, it's not commune, there's no N, notice it's commutative, all right? There's a commutative property of addition, and there's a commutative property of multiplication. Now, basically, when you hear commutative, what I want you to notice is this note right here. It means that you change the order without changing the answer, all right? So the commutative property of addition would say that A plus B gives you the same answer as B plus A. In other words, when you add, the order that the numbers come in doesn't change the answer. So here's yourself an example, like 2 plus 3 is 5. Well, 3 plus 2 is also 5. So notice 2 was first and 3 was second. Then they switched the order and 3 was first and 2 was second. All right. The same thing works on multiplication. A times B is the same thing as B times A. So 4 times 5 is 20, but 5 times 4 is 20. So in multiplication, you can flip the order, or in addition, and the answer won't change. That's why in algebra, x times y, remember we just write xy. So when they're together, there's nothing between them. It's understood to be multiplication. But when you see xy and when you see yx, it's exactly the same thing. They're identical. So you could actually change yx to be xy and you'd have exactly the same thing. So they are synonymous with each other by that commutative property of multiplication. So commutative means changing the order without changing the answer. Now, associative property, basically that means you change the grouping without changing the answer. You don't change the order, you change what's grouped together. And there's an associative property of addition, and there's an associative property of multiplication. Now notice, A is first both times, B is second both times, and C is third both times. So I didn't change the order. What I changed was the grouping. Now we're going to talk about order of operations in a minute, but remember the first thing you do in order of operations is parenthesis. So here you'd have to add A and B first and get that answer and add C. But on this side, you got to add B and C first. Same thing here. First, on this side, you got to multiply A and B first. On this side, you got to multiply B and C first. So what's grouped together is different. A and B are grouped together here, but B and C are grouped together there. So look right here. 2 plus 3 plus 4, 2 plus 3 plus 4. But over here, the grouping, here I've got the 2 and the 3 grouped together. Over here, I've got the 3 and the 4 grouped together. So I've got to do parentheses first. Well, 2 plus 3 is 5. 5 plus 4 is 9. Well, on this side, I'm forced by parentheses to do it first. So 3 plus 4 is 7. But 2 plus 7 is still 9. So I changed the grouping, but I didn't change the answer. Similarly on multiplication, I've got to multiply the 6 and the 2 first and get 12, and then 12 times that remaining 3 is 36. On the right side, because I've got to do parentheses first, I've got to say 2 times 3 is 6, and then 6 times this first 6 also gives me 36. So I can change the grouping without changing the answer. Now, sometimes you make up shortcuts that are not right. And that may have happened to you in the past. Just because there's a parenthesis in the problem, that doesn't mean it's associative property. See, look down here. 2 plus 3 in a parenthesis plus 4 equals 4 plus 2 plus 3 in a parenthesis. This is not associative property of addition because I haven't changed the grouping. See, over here the 2 and the 3 are grouped together. Over here the 2 and the 3 are grouped together. So there's an example of, even though they're parentheses, that's not associative property of addition. What I've done is change the order. Parenthesis plus number equals number plus parenthesis. And when you change the order, that's commutative property. So changing the order is commutative, changing the grouping is associative. All right, let's look at some more. Identity property. Identity property, what I want you to remember is you end up with the same thing you started with. Okay? Now, there's a number that you can add to any other number that will leave it the same. Now, you know what that is. That's 0. 0 plus any number doesn't change the number. So that's your identity property of addition. Any number plus 0 or 0 plus any number, the order there doesn't matter, is going to give you your original number. Whether you had 3 plus 0 or whether you had 0 plus 3, either way, the answer comes out to be 3. Okay? Now, similarly with multiplication, there's a number that you can multiply another number by and not change it. Now, think about what number that is. Okay? So you can multiply a number not by 0, but you can multiply a number by 1. Okay? So that's your identity property of multiplication. Any number times 1 or 1 times any number is that number. So whether you have 5 times 1 or 1 times 5, you get 5. So that's your identity properties of addition and multiplication. Now, when you hear inverse, what I want you to think of is when you put inverses together, you get back the identity. So think about what was the additive identity. Okay, what number did we add to any number to leave it the same? See, we added 0. So 0 is our additive identity. That's the number you can add to any number. So with an inverse property, you're supposed to end up with that identity of 0. So what do you add to A to get 0? You have to add the opposite of A. So down here, what's the additive inverse of a positive 4? It'd be the opposite, a negative 4, because 4 plus a negative 4 is a 0. So negative 4 is the additive inverse of 4. Similarly, positive 4 is the additive inverse of negative 4. So additive inverses are what you add together to get the additive identity of 0. So what's the additive inverse of a negative 1/2? Well, it'd be a positive 1/2 because that's what you would add together to get 0. Similarly, if you had variables, if you had an x, a negative x would be the additive inverse. Now, sometimes you'll hear the word, instead of additive inverse, you'll hear the word opposite. I'll use those terms synonymously. So the opposite of a negative 3 is a positive 3. The additive inverse of a negative square root of 7 would be a positive square root of 7. Now, multiplicative inverse means what you multiply by to get the multiplicative identity. So what number do you multiply by and leave it the same? That'd be a 1. So what would you multiply A by to get 1? We'd have to multiply it by 1 over A. Now, a phrase that you're more familiar with is reciprocal. So multiplicative inverse is the same thing as reciprocal. See, what's the multiplicative inverse of 3? Well, 3 means 3 over 1. So what would you have to multiply 3 over 1 by to get 1? We'd have to do 1/3. So 1/3 is the multiplicative inverse or the reciprocal of 3 over 1. So reciprocal multiplicative inverses mean that you flip the numbers. So what was the numerator becomes the denominator. What was denominator becomes numerator. Now, you don't change the sign. You just flip it. So the multiplicative inverse of a negative 2/5 is a negative 5/2. You simply flip it. Because think about why. Negative 2 times a negative 5 is a negative 10, is a positive 10. And then positive 5 times a positive 2 is a positive 10. So you get that 1. Let's flip back. All right, that flipped on me. So the multiplicative inverse of x over y, you flip it, you'd get y over x. And see, x times y is xy. Y times x is yx. Now remember before we talked about that commutative property of multiplication. So yx is the same thing as xy. So anything divided by itself except 0 divided by 0, of course, is 1. So there's your additive inverse properties. All right. Distributive property of multiplication over addition, or distributive property of multiplication over subtraction. Now, it only works over addition or over subtraction. You don't have a distributive property of multiplication over multiplication. Okay. So what it says is, if you're multiplying a number outside of a parenthesis by a sum, now remember, order of operations says that you would have to add first and then multiply. This gives you permission to switch the order. So you would say A times B and get AB, and then plus, if that's plus, and then A times C would give you AC. So 3 times X is 3X, plus 3 times Y is 3Y. Now here you've got a negative, like a -1. So that negative's got to be distributed. So a negative times a 2 is a -2 plus, and a negative times a Z is a -Z. Now you know that adding a negative is the same thing as subtracting a positive. So you could rewrite -2 plus a -Z as a -2 minus Z if you preferred. Similarly, it works over subtraction as well. So A times B and then minus that A times C. So here's an example. You'd have 2 times K, which you write as 2K, and then minus, and then you'd have 2 times 4, which of course is 8. So you'd have 2K minus 8. And then here again, you have to distribute that negative. So negative times 6 would be a -6, and then there's your minus. And then a negative times a Y would give you a -Y. Now remember, you can change subtraction to addition. If you do that, the first term stays the same, that minus turns to a plus, and that second term turns to its opposite. So that first term, -6, would stay -6, minus would turn to a plus, and then this second term would turn into its opposite. So the opposite of a -Y is a positive Y. So this has the same value as this. Okay, so that's a quick review of your properties. Now, I'll remind you here about your order of operations, which I'm assuming you know. Okay, so the first thing you do are parentheses. The second thing that you do are exponents and roots. We'll talk about in the next video, or another way of kind of doing exponents. So exponents and roots. The third thing you do is multiplication division, left to right, whichever comes first. Okay, so you don't always multiply before you divide. It's whoever gets in line first. And the last thing you do is addition subtraction. And again, you don't always add before you subtract. That again is left to right, whichever comes first. So let's look at a quick example. All right, look what you have here. All right, here's the original problem. 4 minus 2 cubed plus the 1 minus 5 in a parenthesis times 2 minus 3 plus 1. Okay, you can't just jump over and do what you know to do. You have to follow order of operations. So remember, the first thing was parentheses. So I'll look, are there any parentheses? Yep, there's a parenthesis right there. So I've got to do that first. So 1 minus 5, of course, is a -4. Now notice what I did. Everything else, I just copy. It stays exactly the same. Do one thing per line. If you don't, you're going to get the wrong answer. Then you start over. There's nothing else inside of a parenthesis to do. Now I know I've got a -4 inside that parenthesis, but there's nothing inside of the parenthesis to do. So I start looking for roots and powers. Well, see, here's a power. So I've got to do 2 to the third. Now remember what 2 to the third means. 2 to the third means 2 times 2 times 2. And 2 times 2 is 4, and 4 times 2 is 8. So 2 to the third is 8. Now we talked about this. This isn't a -2 to the third. This is minus a positive 2 to the third. That exponent only goes with what immediately precedes it. So what precedes it is the 2, not the negative. So again, I do one thing and then everything else got copied. The 4 got copied, the -4 got copied, the 2 got copied, the minus, the 3, and the 1. So one thing per line, and every time you start back to the left to start over. All right. So now I look for a multiplication division. We'll see there's some multiplication. What's a -4 times a +2? Well, that's a -8. Everything else got copied. So there are no more multiplication division. So now look for addition subtraction. Well, this subtraction occurs first. It got in line first. So it's done first. And 4 minus 8 is a -4. So everything else just got copied. Then I start back over. Now addition comes next. Well, a -4 plus a -8. Remember, a negative plus a negative is a negative 12. And again, everything else gets copied. Then this subtraction comes next. -12 minus 3 more would be a -15. Okay? And then -15 plus 1 is a -14. So you can't jump over here and go, oh, I know 3 plus 1 is 4, so I'm just going to subtract 4. That will not get you the same answer. So you've got to use your order of operations. Parenthesis, do all of those left to right, whatever comes first. When you've got all those done, do all the exponents and roots left to right, which, you know, in the order they come. Then multiplication, division, left to right, and then addition, subtraction. But if you do one thing per line and always start back over on the left side, you won't get confused. So I hope that review was helpful. Okay. So if you have any questions, you got my email address, please contact me.